Hello again. We are finishing up this unit on factoring by talking about another very special case, and that is factoring perfect squares. All right, so let's get started. Remember when we were multiplying a binomial by itself and what the answer looked like. If I had 7x plus 12 squared, that is actually 7x plus 12 times 7x plus 12 again. And when I multiply that, I get 49x squared plus 84x plus another 84x plus 144. So that simplifies to give 49x squared plus 168x plus 144. If I had something like 2a minus 5 squared, that would be 2a minus 5 times another 2a minus 5. And multiplying all of that gives me 4a squared minus 10a minus another 10a plus 25. And that simplifies to 4a squared minus 20a plus 25. Okay, third example, if I have 9pq plus 1, and that is squared, I get 9pq plus 1 times another 9pq plus 1, which multiplies to give 81p squared q squared plus 9pq plus another 9pq plus 1. That simplifies to 81p squared q squared plus 18pq plus 1. Okay, so I want you to see if there is a pattern here. There definitely is. The outside terms are perfect squares. So everything that I've highlighted in red is a perfect square. If you multiply the square roots of those outside terms and you double that, then you get the middle term. Okay? So we could write it as a squared plus 2ab plus b squared, or if there was a minus in the middle, a squared minus 2ab plus b squared. So the question then is a plus b all squared or a minus b all squared, depending on whether there's a plus or a minus attached to that middle term. Okay, so the factorization of a squared plus 2ab plus b squared is now a plus b squared. You just have to figure out what a and b are supposed to be. And the factorization of a squared minus 2ab plus b squared would be a minus b all squared. So let's look at some examples. If I have 25b squared minus 60b plus 36, well, the square root of the first term is 5b. The square root of the last term is 6. So in order for this to be a true perfect square, I would need to multiply those two things together, double it, and it would have to be the middle term. If it's anything else, then we do not have a perfect square. Well, if I take 2 times 5b times 6, that is 60b. The only difference is I've got a minus in the middle, but this is still a perfect square. I just need to remember that I need to put a minus in those parentheses. So this is a perfect square, and my answer is 5b minus 6 all squared. All right, 81x to the 6 plus 72x to the third plus 16. If I square root the first term, I get 9x to the third. If I square root the last term, I get 4. Now, if I multiply those together and double it, do I get 72x to the third? Yes, I do. So that means this is a perfect square, and I will factor it to get 9x to the third plus 4 all squared. Okay, here's the geometric explanation for why this works. So here's what a squared plus 2ab plus b squared actually looks like. I've got an a by a square, and I've got two a by b rectangles, which means they have an area of ab, and then I've got a b by b square in the bottom right. Okay, they all make a square that is a plus b times a plus b. Which means that the factorization is a plus b all squared. All right, now again, sometimes these are in disguise. So if I had 8w to the third plus 40w squared plus 50w, I can factor out a 2w out of both of those, leaving me with 4w squared plus 20w plus 25. And that can factor to be 2w times 2w plus 5 all squared. If I have 18x squared y plus 84xy plus 98y, I can factor a 2y out of those, and that leaves me with, in parentheses, 9x squared plus 42w plus 49. That should be an x, 42x plus 49. And so that can factor to be 2y times 3x plus 7 all squared. All right, so just be careful when you're doing these. If it doesn't look like a perfect square to begin with, maybe you've got to do some common factoring first in order to complete the problem. All right, if you have any questions, please let me know, and I will see you tomorrow.